Okay, cart is moving along a horizontal circular track. The instant shown, the cart is moving to the right and its speed is increasing. Student claims that the net force on the cart is directed toward the center of the track. Is this claim correct? Why or not? Why not? All right, so in order for speed to increase, so V to increase, I have to have an acceleration or a force going to the right. So that's to increase the speed. And then to circle, I have to have a force going towards the center of the circle. So, because for uniform, this I would not write. Uniform circular motion, like the notes that you would hand in. Uniform circular motion, I know that F is towards center, and uniform means constant speed. So in order to increase the speed, I have to have this tangential component. So, yes is wrong. So no, because the cart has both a tangential acceleration parallel to the track and a centripetal acceleration perpendicular to the track. That is correct. So, let's see. Asteroid is moving directly toward a planet as shown in figure 1. At a later time, as shown in figure 2, the asteroid is closer to the planet, still moving directly towards it. Change to the planet's velocity is negligible. Which of the following correctly describes the change in the total mechanical energy of the asteroid planet system? All right, total energy, asteroid planet system, everything's included, so that has to be constant. So that would get rid of those. All right, energy is constant. Change in kinetic energy of the asteroid. Well, we know as it falls, the kinetic energy is going to be increasing. And so that is going to be this, B. Okay, toy is made up of 4 pieces with the relative masses indicated in the top view figures shown. Toy is initially at rest. Then it explodes, friction is negligible, equation or set of equations that correctly describes the magnitude of the momentum. Okay, so we know that momentum px is conserved, and so that means that pd has got to equal pb, and then py is conserved. So that means PA is equal to PC. So we just need to find those equations. No. That is not necessarily true because I'm going to have different momentum in the total x in the x dimension as compared to the y dimension. PA equals PC, PB equals PD, that looks good. And then no reason to do that. Okay, so that's the, so it's important to recognize that my conservation of momentum is independent in each direction. So. Wheels A and B are connected by a moving belt. Both are free to rotate about their centers. Belt does not slip. Radius of wheel B is twice the radius of wheel A. Okay, because it's rotating with a belt, that means that the linear velocities have to be equal. If you didn't know that before, you know it now, so you can remember. And they want to know about angular motion. So I know that this is going to be omega A times RA. It's going to be omega B times RB. I know that RB, this is twice RA. So in order to be equal, this has to be 1/2 omega A. Okay, because that's the only way they'll cancel so that I get them equal to each other. And so that means omega B is 1/2 omega A. And so that is not there, so omega A is equal to 2 times omega B, and so that would be C. Okay.